How does a miniature circuit breaker MCB work? Let's have a look inside the MCB. We start with a diagram that shows the basic functions of the device. A bimetal strip grants thermal protection against overloads. Against short circuit, the bimetal is not quick enough. Therefore, an electromagnetic trip made with a coil is installed. Both units are connected to the switching mechanism, so as soon as a failure is detected, this switching mechanism opens the main contact. A look inside. Between the upper and lower terminal, the current flows through the bimetal strip, the electromagnetic coil, and the closed main contacts. As soon as a failure occurs, the main contacts open, and a possible arc will move into the arc extinguishing chamber. Using the toggle, the MCB can be turned on after tripping. On the following slides, you'll see the working principle. Upper terminal. Bimetal overload trip. Bimetal thermal protection. Electromagnetic protection. Toggle. Manual operator. Contacts. Switching mechanism. Tripping mechanism. Arc extinguishing system. Lower terminal. Bimetal overload trip. The deflection of the bimetal depends on current intensity and duration. In case of overcurrent, a high current heats up the bimetal, which bends and releases the switching mechanism. This kind of tripping depends on temperature, time, and current intensity. Short circuit demonstration. The electromagnetic tripping device consists essentially of a coil in the load current path. There is a fixed and a movable armature. In the case of a short circuit, a multiple of the nominal current, IN, generates a magnetic field, and the armature will be attracted against the spring. The switching mechanism provides opening of the contacts. The switch-off delay must be as short as possible. The switching mechanism has springs and masses, high switch-off delay, okay so far. With a hammer pushing directly on the main contacts, this time is reduced to a minimum. Arc extinguishing system. The extinction of the arc guarantees fast, reliable disconnection of the circuit. In case of a failure, the contacts open. At this moment, an arc occurs, which has to be led into the arc extinguishing chamber. In the chamber, the arc is split into smaller arcs of maximum 30 volts each, which extinguish themselves. Short circuit trip demonstration. The breaker starts to react. The hammer trip pushes the contacts apart. An arc is created between the moving and fixed contact. 1 millisecond after the short circuit, the moving contact is nearly totally opened. The arc can be clearly seen. 1.5 milliseconds after the short circuit, the arc has now left the contacts and enters the arc extinguishing chamber. 2 milliseconds after the short circuit, the arc is now in the arc chute. The metal plates will divide the arc into smaller separated arcs. The arc voltage between two metal plates is smaller than 30 volts. 2.5 milliseconds after the short circuit, the arc is now separated into smaller arcs. The circuit is finally disconnected. The switching mechanism is released and the toggle is in the off position. 3 milliseconds after the short circuit, the whole operation is done.